Alrighty, I'm hoping to kind of iron out a little bit of confusion on the additional practice. So we're going to work with synthesis reactions first. So usually a simple synthesis reaction is just two separate things that combine to make one thing. And we usually show it as A plus B is going to make for me AB. So this could be something like H2 plus O2 would make H2O. I know that these are going to have a little subscript 2 because they're diatomic elements. And I know that this 2 will happen because it's H is a +1 and oxygen is a 2-. So you need 2 H's to satisfy 1 oxygen. But they're not balanced. So we need to figure out in nature, what is the ratio of hydrogens to oxygens that will produce water completely. So I'm going to put my H and my O underneath the arrow. I'm going to have 2 H's and 2 O's come in. And right now I'm showing that there are 2 H's and 1 oxygen coming out. And I know that that's not possible, so I'm going to need to balance this equation. So the first thing I need to do is double the amount of oxygen that's coming out. And I can't change the subscript because I can't change their charges. That would change the number of valence electrons. But what I can do is add multiple sets. So I can add another set of water, and that would give me a total of 4 hydrogens and 2 oxygens. So my oxygens are balanced, but my hydrogens are now unbalanced. So I need double the amount of hydrogen coming in. So I'm going to say that 2 sets of hydrogen, that would give me 4 hydrogen atoms. So now I know that I need 2 sets of hydrogen and 1 set of oxygen, and that will produce for me 2 sets of water. And that makes sense because on a previous video, we showed just that here. I had 2 sets of hydrogen plus 1 set of oxygen, and it made 2 sets of water. And that is a synthesis reaction. So something on the additional practice, if I'm looking at the ones with the words, 1, 3, 4, and 5, I'm going to go through those, and then I'll talk about which ones will be tested and which ones will not. So if I do number 1 first, that is going to be lead to carbonate, and it tells you that it decomposes. So first I know that lead has a 2+ charge, and if you look on your polyatomic chart, carbonate has a 2- charge. So I'm going to have Pb CO3. Carbonate is CO3, and because it's a +2 and a -2, those charges cancel. Since it decomposes, I'm going to draw my arrow. Carbonates specifically, this is just what happens in nature, always produce carbon dioxide. So I know it's going to produce carbon dioxide for me. And then they make a metal oxide, PbO. Because Pb is a 2+ and oxygen is a 2-, I don't need anything on the bottom. I have 1 Pb coming in, 1 going out, 1 carbon coming in, 1 carbon going out, 3 oxygens going in, and 3 oxygens going out. I don't need to balance. The decomposition of a carbonate will not appear on the test, but I did want you to know it. For the next one, number 3, you have silver oxide decomposes. Silver is an exception to our rule. Even though he's a transition metal, he's always going to be a +1 charge. Oxide is always going to be a 2- charge. So when I make this formula, it's going to be Ag2O. When he decomposes, silver is a stable metal, so it's going to make Ag plus oxygen gas. So because he's a stable metal, he's not reactive, it'll make silver by itself, and then oxygen gas comes out. Where carbonates will produce carbon dioxide and a metal oxide. Now we need a balance, so we have AgO 2, 1, 1, and 2. So I'm going to put a 2 over here. So that'll give me 2 oxygens and 4 silvers. And then I can put a 2 here, and that will give me, put a 4 here. And that will give me 4 silvers. All right, something like this can be on the test because it's a simple decomp. The next one is going to be number 4. So number 4 says that we have potassium chlorate, and it's going to decompose. Now, if you were in my earlier classes, I told you this and it was incorrect. We were working with sodium chlorate, so pay special attention if you were in my morning classes. We have potassium, which is a +1, and chlorate, which is ClO3 with a -1. Those charges cancel. Chlorates, you guys were actually correct. They're going to make a salt, which is going to be KCl, plus they make O2. So they're going to release oxygen gas. They were really strong oxidizers. Then we need to balance. It'll be KClO. So we have 1, 1, and 3, 1, 1, and 2. I'm going to double this guy. That's a 2, 2, and a 6. Put a 2 here for a 2 and a 2. And then I'm going to put a 3 here. That'll give me a 6. So chlorates are strong oxidizers. They'll release oxygen and they'll make a salt. That will not be on the test. The last one that I'm going to do is going to be the opposite of number 1. So we're going to take magnesium oxide, MgO, plus carbon dioxide, CO2. Well, you know that a metal oxide and carbon dioxide make a carbonate. So here, we'll just add it all together. It'll be MgCO3. Then we need to balance. So we have Mg, C, and O. You have a 1, 1, and a 3. You have a 1, a 1, and a 3. It's balanced. This one will not be on the test. That was your number 5. So you need to know a simple synthesis, but the carbonates and the chlorates you don't need to know, but I wanted you to know how to do all of these. The ones that you do need to know for the test is going to be like number 7. So in number 7, you have carbon dioxide plus H2O. And that's where we wrote in our notes, and we put a star on this one, that non-metal oxides in the presence of water will make for us, non-metals are negative. We have hydrogen plus hydroxide. So the negative of this non-metal will combine with the positive part of water. So it's going to make an acid for me. So I'm going to have H. What I have left is C and 3 O's. So it'll be CO3. From the polyatomic chart, you know that carbonate is a 2-, hydrogen is a plus. So it'll be H2CO3. And we know it's an acid because it starts with H. The other one you need to know is something like number 9, which is barium oxide, +2 and a -2, so those cancel, plus H2O. So with this one, we had a non-metal oxide. It made an acid. So a metal oxide is going to make a base. So that'll be BaOH. Now we need to check charges. Ba is a 2+, OH is a 1-. So now we need parentheses with the 2 on the outside. So we have 2 H's, 2 O's, 1 Ba, 2 H's, 2 O's, and 1 Ba. And then OH means that it is a base. So let's go through that one last time and review. So if it's a carbonate or a chlorate, that will not be on the test. But if it is a non-metal oxide in water, that creates an acid, or a metal oxide in water that creates a base, or a simple synthesis, or a simple decomposition, those will be on the test. Hopefully that's helpful.